And so one more note here for those of you who may not be familiar with XP Solutions. We have a long history of providing high-performing software solutions. And our intention is to make sure that in your work you can model with confidence. So this means that we strive to provide excellent customer service and support, and that we have continuing education opportunities like these for engineers in our industry. So today's presenter is Zach Sample, our Stormwater Products Manager. He has over 10 years of civil engineering experience in site design, stormwater planning, and hydraulic analysis. Zach has performed a number of advanced water resource studies, including hydraulic and water quality system assessments, as well as 1D and 2D hydraulic river and floodplain studies. During his time with XP Solutions, Zach has helped hundreds of clients with their models, so his voice may be familiar to some of you. So thank you all for joining us today, and welcome, Zach.
Thanks, Catherine. Thanks, everyone, for joining. Right off the bat, I have a question for all of you. So I'll launch a poll, and you can all click on your screen when you see this. Just want to see, as you can see the question there, how many commercial development projects do you have per year? Just kind of a general sense of kind of what everyone attending has. You have more than 10, let's say, well, less than 10. There's also a kind of couple of the questions at the bottom there. Have you ever used Pervious pavement on a project? Have you ever used underground detention facilities on a project? Those are really the kind of solutions that were looked at for the project that I'll be showing. Just curious how everyone here would line up with that. So go ahead. Looks like most people have already checked. Go ahead and hit those buttons that apply. I'll give you another second, and I'll share this in a moment once it's done. All right, great. So I'll close that and I'll share. So you can see what everyone joining looks like. Looks like everybody has, a number of development projects per year. And not surprising, the underground detention facilities are pretty common. And I guess I would say that the Pervious pavement options are really what has begun to kind of increase in popularity as a solution. So we'll look at how on this specific project that I'll show kind of how these two were looked at. Great. So the agenda today, we'll look at a pretty high level idea of commercial land development project workflow. We'll look at a real project and real constraints around that project, and I'll really just walk around the different ideas that were looked at on how to solve the stormwater issue for this project in particular, without getting into too much detail on any one thing. So to start, a little bit of a kind of a workflow, so to speak, for a commercial project. Now, I'll speak to private consulting engineers and city reviewers in a second, but a commercial project really doesn't start with either of those groups. Okay, so we have this commercial, what I'll call box store, wants to open a new location. So that could be a pharmacy, could be a grocery store or a retail store. So ultimately, they want to expand. They want to open a new location. They are the driver for this process. So before something can be built, there needs to be a bit of a blessing from the city or county, i.e. an approved permit, right? That's what's happening here. So before you can build something, the city needs to approve it with this permit. Now, the city, county, is the safety steward of the community. So the permit requirements are focused on proving minimizing of potential social, environmental, and welfare impacts. So that's the idea here. It's not just that the city, wants to, be a hurdle to jump over. They're in charge of the safety for the community. Great. So we need to get the approval of the city. They're the safety steward. And turns out, in most cases, that commercial big box group or box store group, their specialty, their daily items that they think about aren't how to, lay out, construct, and permit a store, right? It's on their actual service. So you can imagine that box store is going to hire an engineering firm to lay out the site and ultimately get the approval from the city and county. I always like to show the givens, right? People, if you're kind of new from college, right, you're always kind of handed the givens to start a project. Well, this would be the given in this case. So we have the existing site, and that's kind of the starting point. The store is going to go in the southern portion of the site. There's already a store in the northern zone. That's going to stay there. So it's the southern portion where we want to build a new store. And that's it. This is the info we start with. And we need to, specifically on the stormwater side, create this. All right, we need to, all right, this is where the store is going to go. Here is the parking and the sewer and all the elevations, all the detail to build it. Well, the detail to build it and, of course, to review that that makes sense. That's what the city will do. So for this project, we looked at design constraints. Well, the first is there's a first flush requirement. Okay, so we need to hold on to, retain, and infiltrate the water quality event on site. In this case, first inch of rainfall runoff. So we have the first flush we need to hold on to, and then there's no increase in the flow for the 2 through 100 year rainfall events. That's pretty common. In this case, we aren't looking at volume, it's just peak flow. A lot of cases, a volume also can't be increased, right? So the existing site, what's the peak flow and what's the peak runoff volume? Many cases you need to mitigate your developed condition flows and the volumes to not exceed the existing. So looking at a development project, beyond just stormwater items, there's a large minimum parking requirement, as you kind of would expect. A store's going to have lots of customers, so that means a lot of paved area. So the site's going to be highly impervious. And something else, that kind of high traffic or heavy truck driving routes. So there's an idea, we'll talk about pervious pavement. Whether or not this is really a concern in this case, in this area, it was thought of that loading zones and where areas where a heavy truck will turn its wheels a lot, that might really erode a pervious solution. Okay, so that needs to be taken into account. And also there's adjacent sensitive ecological areas. So we can't disturb too much of the site. There isn't a requirement, let's say, to replace the ecological zone that you encroach upon. That's in some areas. In this project we didn't have to, but just minimize the amount that we were going to newly pave. All right, so considerations on the site. We'll look at this more in a second, but if you can remember from the pictures, there's really no room for a single conventional detention basin, right? We would have to have too little parking, or it wouldn't work on our site. So we have to get more creative. There's multiple drainage paths. We'll see how the roof drains, the parking, different parking zones. Those all kind of create problems for us when they come together. Ultimately, there's an existing storm system that we're going to connect into, right? That's pretty common. So that's, of course, a constraint, a consideration. We need to make sure we can match into that system. And for pervious solution, there was maybe a thought of, well, what if this was clogged? Okay, so we could look at kind of a clogged scenario of the permeable pavement. And just to reiterate, this is a real project that actually incorporated kind of the final design that I'll show. Though I have, removed the street names, removed some stuff to make it more generic. And also, I am showing all the design considerations, right? Often you might only show on plans the final one. Well, here I'll be using XPDRAINAGE as the tool. We can look at these all kind of side by side, so you can see the thought process across this project. For a bit of a background on the different options, permeable pavement. That's, porous asphalt, concrete, or pavers. Basically, that's a no fines aggregate mix or spaced blocks. Think of it like that. So because we're able to have water immediately get down through this, as you can see that cross section down below, we can increase the effective developable area quite greatly. So whereas we might have to have a pond or a swale or some series of pipes, well, we can just have this porous area that you can park on top of. So it's pretty fantastic for that. And it's also a really great tool to infiltrate that runoff volume, that initial first flush volume. And in doing so, we're going to really be able to reduce the amount of pollutants that are going to be on our site. A big one is temperature. I'm physically in Portland, Oregon, so cold water fisheries. We want to knock down the temperature running off our site of the stormwater as much as possible before it runs into the streams. Okay. Uses, might be straightforward. If you're not familiar with this, it looks like fewer people have used this option. Pervious pavement can be used pretty much everywhere, parking lots, walkways, and driveways. That's how it's used on this project. So there's a lot of discussion about how fantastic this is for main arterials and highways, right? It has really the same life cycle that a normal asphalt roadway would have, but it's a great reducer of spray and increase in visibility. So one thing to watch out for isn't perhaps freeze-thaw cycles, but lots of discussion about how that isn't really a disturbance as much as sediment loads in these systems. So considerations for permeable pavement. So we really need to consider a few things, which are practically speaking, in most cases, very hard to do, really cumbersome. But we'll find, that's one thing that XPDRAINAGE in this case does really well. So we actually need to assess the hydraulic behavior through this facility. Among those items, the hydraulic behavior, what about site slopes? Okay, so we need to look at how the flow actually goes through the filter zones, how it will move down along that pervious area, and what if the site has some sort of slope along the parking area? So you could have a perfectly flat parking zone because these the infiltration will occur directly in the parking area with the permeable pavement, but you might have to tie in. You might need to meet a couple areas that are at different elevations. So whether you want to or not, you might have to put it at a slope. Well, you might have water bubble up out of one end. So we'll look at that, how slope along these facilities is often something overlooked, but we'll see how big an impact that could make. As I mentioned, kind of the true layering of structural fill. Other item just in the general hydraulic behavior is there's likely many different outlets to a parking area like this. You're probably going to have under drains, maybe not. If it floods, okay, in a high flow event, you're going to have curb cuts. So you're going to have weirs kind of all across around that parking area. To represent all of that in Excel, which is something I had done in the past, right? In Excel or some basic tool, really hard. So we'll see how kind of easy this is to incorporate and to check out, even just in a few minutes in XPDRAINAGE. The other item is a storage tank underground. And this could be an above ground rainwater tank, let's say, but we're looking at below ground collection tanks. These systems vary greatly. These are manufactured in a whole different media by different groups. So corrugated, plastic, steel, precast concrete, milk crates, as I'd call it. So that's the general concept. So as you can imagine, there's so many different things you could do. Having flexibility and how you can assess that is really important. The main idea of why this is so advantageous looks like there's, over a third of the people tuning in have used this before. This lets you basically have that detention pond idea, but underneath parking. So right away, a really big win. It might be the make or break aspect of a site. You might need to have 30 extra parking spaces, and that lets you have a certain store. That lets you add in kind of an add-on commercial retail spot on your site. So big ones to look at: void ratio, what's the true storage, and all the types of infiltration that you can get around this. You probably have some sort of base infiltration, infiltration under your facility, infiltration on the sides of the facility. So being able to assess all of those pieces is something we're going to do in XPDRAINAGE, and see how this ties into the whole drainage system, not just, again, using a spreadsheet or using one tool to look at just the basin, but seeing how that incorporates itself into the rest of the system and impacts is really important. So let's just jump right into this project that I can show. So here it is. So here's a real project, and there's lots of details here. Just for the sake of time, I'm going to be, kind of high level with how I look at this. So here's the project site. If anyone's not familiar with XPDRAINAGE, probably a pretty intuitive interface if you've ever used Windows computer or some sort of CAD or GIS software. If you use the ribbon, I loaded in background data. Basically, I walked left to right across this ribbon to finish the project. Load in background data, build up the system, analyze and look at the results. Okay, so what we're looking at right now is one of the kind of finished ideas. That's on this tree view on the left. There's this phase manager. This is really looking at all the ideas side by side. That's kind of the point of design. We don't know the answer before we start. So I have, an existing site, different tank options, different porous paving options. I'll just jump right to, actually how I started this project. So here, this is blank, and I'll show kind of how this began. That's kind of a useful way sometimes to get your mind around how we moved into those later stages. So the first thing might be, here's my site. You can see here's the box store in the middle. Parking really has to go all around it. That heavy loading drive aisle, you can see here, is where there's no parking, right? So this needs to not really have any porous solutions. So let's kind of start a project. There was some work already done in CAD, so great, we can use as much as there is. So I could start with some catchments which were already placed as a starting point. So these are in CAD, and that's only the area, right? Well, I could use a template. It's a really great option. So say, hey, this is my developed land use. Great, import those items. And we'll see, sure enough, I've imported the catchments for this site. Based on that template that I used, here's kind of all of the hydrology input for that land use type. Well, what we'll find is maybe I want to change that. So I could individually make those changes. I could also use this, this tables option. And we'll see here that I have, you can see the site, and I can click through these items to see, well, there's some roof areas, right? And this site's pretty small, so I might change what, the default of 8 minutes, I might change this to be, 5 minutes for the time of concentration for all of the site, because it's just catchments are so small, right? It's kind of the minimum you'd use. So great, so I've changed all of the TCs to be 5 minutes. And looking at the site, there's the roof area for the building. We'll see there's going to be downspouts that tie in. Well, that's probably 100% imperviousness. This curve number is the Pervious curve number, right? So if I have 85% imperviousness, it's going to weight 15% of it will be use this number. But you can see in the schematic these first 3 catchments are all roof areas. They're all 100% impervious. And there may be some very detailed work to go and find exactly the weighted values for imperviousness on the site. I might say that they're all about 92%, just for example's sake right now. And we'll see that if I was to edit one of these items, we'll see that these values have changed. All right, so a 5-minute TC and 100% impervious for one of the roof areas. Right, so the hydrology pretty straightforward. And there also was kind of as a starting point, there was a just very preliminary drainage layout done in Civil 3D. So I can import that pipe network. So I'll say import, and we'll see that right away I have these downspouts from the roof areas, how this all connects together. Ultimately, this site, you see this lower manhole and this piece of pipe. This is the existing system we're tying into. Okay, so we have that represented. You know, we could have delineated that or laid that out in XPDRAINAGE, but you know, we had some data. So let's start with that. And from here, we want to kind of craft our solution. Clearly, if there's no mitigation, well, we're going to be increasing the flow, right? We're going to be paving a lot more of the site. So we need to place some sort of facility. So I could start by this lower culmination of all this flow. I could change this. I'd say change template. And I can make this be a tank. I want that underground tank. You see it changes the icon. And I could change that outline. So, you know, just for example's sake, I'm just going to put something in here. Great, so here's that outline. I could twist and turn that. I could move this around. And one of the great things about XPDRAINAGE is that I'm very quickly laying out. We can see what this looks like. I'll say, all right, this is 4 feet deep. And since it's going to be the same information, great. Just vertical walls. Here is my area. So I can very quickly, I'll show the schematic, set out what this is. So if I say, hey, there's a 6-inch freeboard and we have about 95% of void space, that might be a little high. Any work you do, we could save and use that as a template from here on out. So if I want to add more storage facilities, use that in the future, great. So it's very quick to lay out the detailed system just by kind of modifying that existing pipe network. So one thing we could do, great, here's this detailed system, very real to how it's going to be. We can also respecify some of the inlet locations. There might actually be, this is the inflow point into this facility. And this is really quite valuable because it's going to let us have these pipe lengths and the pipe inverts and slopes all be very realistic. Okay, we're not using some sort of schematic system. Maybe the inlet for this parking area all drains down to here. All right, so getting away from that node and link idea where maybe just this point would be the node and the pipes connect. Well, the pipes are going to be too long. They're not going to have the right slope. We're going to lay this out exactly how it's going to be built. That's really the point of XPDRAINAGE. So right away, I've just made kind of my first guess. I have all the system that's going to drain into this facility. I happen to have that as one of these other phases. So here's a tank. I modified this a bit. Oh, yeah, one thing I added was outlets. So the complexity with these underground vaults, we'll look at how it's kind of similar complexity with those pervious pavement options. There can be a whole different range of either under drains or outlets. Configuring those is really important. So you see here I have a multiple stage outlet, and you can see in this case I have a orifice and a weir. Okay, so at different levels those will engage, and you see this is that depth outflow curve. You can kind of see what's happening. We could get as detailed as we wanted to get. If there was good capacity to infiltrate under our facility, we could add in base infiltration, side infiltration rate, so on and so forth. So very quickly we laid out this system, and you'll see here's my kind of first guess at the tank size. There's a a phase that's called size. Well, you can imagine that's one that I've upsized a bit. This is actually the final tank that's used, but we'll look at that last, okay? So here's my first guess. I could just run the software, right? Kind of guess and check, see how big this needs to be. I could also use some sizing tools as maybe a better starting point. So I could go to a quick storage estimate, and you'll see here the software automatically looks at all of the connected inflow areas. It's about 1.7 acres. And let's say I know my existing 100-year discharge rate is pretty low, just under 1 cubic foot per second. Calculate, and this is going to give me a range for a good starting point for this facility. So you can apply that, great. That'll increase the size of our facility, whatnot. I just want to jump over into the Pervious option. So, oh, actually I could show this right here. So here you get an idea of what we're looking at on our site. I'll just show this profile. And this is so important, right? So understanding what's happening, beyond just a spreadsheet, beyond just simple tools, seeing it all in the plan view and how it all connects together, and then really seeing this profile, how making sure these all daylight out together, making adjustments as necessary, really, really important to make these tweaks. Okay, so here's our facility. So that's what our storage tank option looks like. And now I can go over to one of the under drain options. So there's two options I have here. Now, one has an under drain and one doesn't. So I can look at one of these facilities. You see one, I might say, you know what, here's an under drain. What we found out, right, if you have an under drain, the water very quickly leaves these systems. So it's not ideal for larger kind of attenuation, right? We want to kind of have all the void space fill up in this facility. So using no drains allowed more attenuation on our site. A lot of options you have for the paving depth. Is there some sort of membrane? Is there some sort of filter restriction between the paving and the underlayer? Okay. And a big one's the slope. Okay. We're going to see that likely in the real world, you're going to have some sort of slope across your parking area and how that affects this system. So I could show one of these. We'll see this long section. We can see here is our porous parking area with this under drain pipe. So that water, as soon as it gets through this, it's going to pretty readily get into the storm system. You can imagine not going to do a lot to knock down the peak flow from our site. So another option was to have no drains. We can look at that same flow path, right, with no drains. And in fact, I think this one, the slope on the site is actually more accurate here. It's about 2% for this facility. I can edit right through this long section. So about 2% is actually what the slope would be. The other one was a little too flat. So to meet up with these existing sections, you'll see it gives us quite a bit of fall across the site. Once this fills up, you can imagine we're going to have some overflow here, which kind of isn't what we want. So I'll just run the assessment. It'll just take a second. So I'm running all, how many, 6, 7 different phases, different ideas, right? So the existing site without anything and the existing land uses and all the different design ideas kind of side by side. As we'll see, of course, I'll show the upsize tank idea, how that we ran the initial guess using that volume size. It wasn't quite enough, so we just kind of bumped that size up and how that was our solution. Okay. Again, any questions going through this, by all means type those in and I can speak to those. I think everything so far that's been asked has been answered. So we can look at that. So a couple things that we'll find is that, well, we're hoping to over-mitigate the large events by holding on to the flow in these pervious areas. Clearly the roof areas aren't being treated. So what we'll find is how the flows off the roof, and actually the flow in this upper catchment is really still too great. So let's look at that right now. So first thing I can do is to just go back to a profile. So this again is the no under drain phase. Let's look at one of these systems. So I'm looking at our range of rainfall events, water quality events, 5-year and 100-year at the moment. So I can go to the 5-year event, and you're going to see we're already overtopping this facility. All right, so we're representing how this works. We're representing the outlets on this side. But as this fills up, you see that indicator shows that we're spilling over the edge of this facility. Okay, that's really a problem for us. All right, maybe we thought that we could get all the storage in this whole parking zone, but really we can't because it's on a slope. So let's look at that in a little more detail. All right, we could look at the results. Obviously, we could look at the graphs and the trends. I really want to see this 3D view. This is kind of a simplified version, right? We're just going to show this basic rectangle. And we can see how the water really fills up and overflows this kind of the toe of this site. It doesn't look like a lot, but realize this is freely flowing over this edge. So that is going to have flow over this part of the parking area and probably right down here out of our site. Okay, that's not what we want, right? So here's another way to see that, how that would work. See, only a portion of this is filling up. And we can look at, let's go to this phases report option. Let's look at a summary of the existing compared to the different porous paving options. So right now, I'm just looking at the 5 and 10 or 100-year events for simplicity. You'll see that the existing outflow is about 0.3 cubic feet per second. We itemize each outlet and a total, so there's a duplicate here, so there's 2 of the same. So you see the under drain much higher, right? We aren't really attenuating flow. We're almost up to 1 CFS. Under drain, wow, we're still discharging a lot of flow. So I could look at the individual stormwater controls and I could see the 3 different porous asphalt areas. For the 100-year event, there's almost no outflow. So we're almost totally containing all that volume. But the problem is those roof areas and this parking area up here is still contributing a lot of flow. So that is kind of busting our existing conditions, even though we're way over attenuating the rest. So that was kind of the idea, maybe with just these 3 zones, without putting porous paving on the trucking route, we could over attenuate and meet the needs. Looks like we can't, right? Something else we're seeing here, in red, we're seeing that this pipe is undersized. Right, if I look at the results for our connections, we'll see in red pretty clearly, oop, surcharged. I don't want to upsize that pipe. So I left a few undersized pipes and a few problems in here just for the sake of the presentation. It's kind of fun to spot those as opposed to seeing a perfectly clean, done model. So I'd jump in there and I could upsize. This pipe looks like it's a 4-inch pipe with this downstream connection being 6-inch. So it's a little roof lateral. Maybe we'd increase this all to be 6-inch pipes through here. Okay, great. So porous paving, just not going to work. We can't over attenuate enough without treating those roof areas. So the option is, well, let's perhaps look at some of the tank options. So I'll change what I'm representing here. And we'll see again, about 0.3 is the flow for the 5-year event. Both of the tanks, our initial guess, does a good enough job. It knocks the peak flow down. Again, the volume, we don't need to design to here. You might, though. A lot of areas do that. So you can see that, well, we have to figure something else out because the volume's great, pretty great. But our 5-year storm's okay. It's the 100-year event that, well, clearly we fill our tank up all the way. I can show a profile of that. Let's look at this system here. And we'll see how the tank in the 5-year event, it just engages this like midway orifice. At the top in this structure, there's a high flow weir. So, we're really doing a good job of attenuating the flow in the more minor events, though the 100-year event, we're going right to the top and we engage that bypass weir, okay, and we're letting too much flow out. So what do we do? Well, what we did was we had let me go back to that comparison one more time. We were able to adequately knock down this flow by just increasing the size of our facility. So we'll see here's this existing site, and what I did was I just went in and saw, we are looking at the volume, looking at what we need to attain. I just went to sizing calculator, and I can scale this up by another 10%. So that adjusts the size, and we're just going to bump this tank another 10%, and that's going to do the trick. And that's really what was done. You see it, only 10%. It wasn't a huge change, but that was enough to kind of give us this final layout, which was adequate to knock down those peak flows. Again, having this multi-stage outlet structure, all these pieces together is kind of what got us to this being the final design. And actually the scope of what I wanted to cover with this very real design and the different ideas and thoughts which were laid out and kind of looked at in just a really kind of short period of time with XP drainage, which otherwise would have been a really hard exercise, especially the pervious part. So that's really what I wanted to show. I'll jump back to the presentation, and I'll let Catherine jump in and talk about this webinar.
All right, thanks, Zach. So we do have a number of educational webinars coming up in the next couple of months, but on March 1st, we have our XP Swim product owner, Anthony Cooch, and he will be building a 1D, 2D hydraulic model from scratch. So this is a tutorial webinar that was highly requested by our users in the past, and so we hope you can join us. Registration is also available on the site shown on the screen. So that's xps.link/scratch. And all of our other upcoming webinars are also listed on our website at xpsolutions.com. Zach, is there anything you'd like to add?
Thanks everyone for joining today. Been my pleasure. Thanks. And my name is Zach Sample, and I'm happy to chat. So have a great day, and thanks for joining.